Hello, hello, and welcome to everyone. Welcome to the webinar that we've titled Smart Building sorry about that. Smart Buildings Energy Consumption, the Role of Digital Twins. Today with me to go over this interesting topic, we have Pierpaolo Vergati. Thank you for joining us.
Thank you for this amazing opportunity. Thanks to Bilogic for having invited me to this meeting today.
Absolutely, our pleasure to have you. Okay, so let me give you a brief introduction to what we are going to be talking today. So in particular, as the title states, we'll be talking about smart buildings and in particular how we can create a digital twin, a working digital twin through the use of both IoT data and BIM models with some interesting tools along the way. And in particular, we're going to be focusing on all of this aiming at energy consumption, management, and review. So let me introduce us as well. So I am Nicola Migliore. I am the product development manager for the Vcad project over at Bilogic. Vcad, for those who don't know, is a suite of tools that allows us to easily manage BIM models and data within business intelligence tools, in particular using Power BI. So basically allowing us to aggregate and use BIM data and use it to represent also complex information through the use of the actual interactive rendering of the model itself. And with me today, as I said, we have Pierpaolo Vergati. He has a engineering and architectural background, and he is a senior construction project manager working for the GDP group. Okay, so Pierpaolo, let's get started with introducing a little the concept. And if you don't mind, would you give us a brief introduction to what a digital twin is and why it's interesting for us?
Oh, thank you again, Nicola, and most of all the audience today. So we started talking about the digital twin thanks to his godfather, Michael Greaves, an engineer at NASA, that introduced this concept in 2002. In essence, digital twins enable organizations to explore, predict, and fine-tune their products or processes in a risk-free and cost-effective virtual environment. Over the years, the concept has not only evolved in terminology, but more importantly in technology and capability and applications. Modern definition of the digital twin now incorporate most of the buzzwords that today we'll hear from any kind of article online or everywhere. So AI, IoT, advanced simulation, augmented mixed virtual reality. I'd like to show you a very funny example taken from Michael Greaves himself. Consider a crash test of a car. Physically, you can crash it only once, but each test comes with a significant cost. However, with the digital twin of that car, you can simulate an infinite number of crash tests, each one with varying condition, without the financial and material expenses, most of all. This capability allows company to iterate quickly and to optimize safety or some features that they would like to evolve in their prototype.
Okay, very interesting. So basically the reason we really like digital twin is because it allows us to do some very complex manipulation and work on what would otherwise have to be done in real life. So it's basically a digital copy of a real life object that we can play around with more easily.
Oh yeah, in fact, I like to think at a digital twin like a with a bidirectional connection to the real world. So the real world provides the data in the digital twin. Digital twin extrapolate information to reverse this information to the physical world.
Oh, okay. I like this representation. It's very clear. Okay, interesting. So we know that in general, there are many different types of digital twins, which can be applied to different environments. Of course, for our interests, we're going to be focusing on some of them. In particular, of course, construction and architecture, energy and utilities will be the main focus of today's session. But then again, this can be sort of extended to real estate environments in general and smart cities. So another thing that I find very interesting is how digital twins as a methodology can then be applied to a bunch of different scenarios.
Oh yes, the methodology can be applied almost to every kind of industry. Today, the digital twin is a corner shop of digital transformation across all industries. Not only limited to the manufacturing, that was the first original application provided from microgrids. So now we can apply it to the construction architecture, most of all because I am a senior construction engineer, and so I tried to explore this environment and application to all the phases of the real estate, but can be applied to health and care, urban management, aerospace and defense, military environment, so any kind of industry.
Okay, yes, nice. Okay, but let's talk a little more about specifically what the work you're presenting to us today. So Pierpaolo worked on a very interested and quite elaborate project. Why don't you give us a sort of an overview of what's going on in this project?
Oh yes, with a very great pleasure. So this project represents a real case that I solved by creating a digital twin for the client that provided me and asked me to help to discover what's happening to his building. For privacy reason, in this case, I needed to manipulate the BIM model. So you see a BIM model that has been provided from a BIM modeler, Bishoy is the name, but you can find it on the article published from Bilogic. But the data are real data taken from the digital twin. So you can find how it's possible to streaming the model and the data together, integrate them in order to create a real digital twin. A real digital twin, because this digital twin is not so real, but trust me, because it's very interesting how can be exploited all this information in order to create a data-driven decision-making process. This is the most important part of this goals of today.
Okay. So basically, what we're looking at is real-world data that's been slightly manipulated to make it anonymous, and then matched with a BIM of a different project, of course, always for privacy reasons. But the actual insights that we're going to be receiving are real-life insights that we can gain from this information.
Yes, most of all because today any kind of building manager that have to manage a big headquarter or a big company like mine, for example, or the asset manager of a group of buildings, have to take decision. And what's the most things that scare everyone? To take the wrong decision, most of all. So it is important to have the possibility to take the right decision, but how it's possible to take the right decision? Only after having elaborated a lot amount of data. And
yes,
extract from data, from raw data, insightful informations.
Yes, and that is really the important step in the whole process, is transforming that raw data into insights, and we'll get to it in a minute. Before we get to that aspect, tell us a little about which are the pieces of the puzzle that allow you to build this infrastructure and this solution.
Okay. I think that in this image you can see almost any kind of these pieces of the big puzzle that that realize this picture. So the initial step involved the DB model. I wanted to be sure that there were no issues with the data structure of the model. So I decided to verify any kind of aspect of the DB model. I started from a federated model for this project. Probably the dimension of the file weren't too big to be managed with a single file, Revit file, where there was all the disciplines from the civil, structure, electrical, MIP. But I prefer to use the federated model because it is probably the more orthodox project to be applied to manage a project, because there are structural engineer that specialize in structures, mechanical engineer, electrical engineer. So I can receive all of them, integrate in a federated file in order to verify any single aspect of the model. After that, I managed the IoT data that are a typical problem of time series analysis, because we have all the IoT sensor that are linked to a database management system, SQL based. And so I have the identification tag for every single sensor, the data and time string, and then the double value for in this case, for the energy consumption.
Okay.
And then I aggregated it in a data analytic platform. You can see in the lower part of the slide is NIME. And after that, after a process of data wrangling, cleaning, and so on, I deployed it in Power BI in order to create a narrative inside the data. And most of all, I was able to integrate the DB model through the Vcad component. So I was able to integrate BI and BIM.
Nice, very nice. Okay, so we could sort of imagine there are maybe three phases to this project, to this process. The first one would be the data collection, which I assume you're receiving from some IoT sensors that are installed in the building. Are there any particular requirements, or pretty much any sensor is good?
I think that any kind of sensor that is able to give in output data in structured data. I am able to data stream the data in a database management system and connect the database management system output to the input of the data analytics platform.
Okay, great. And so then the second step, which I imagine is one of the more complex ones, is then actually cleaning out and filtering all the data, getting rid of wrong readings, and then making that data really usable. And that's where KNIME came in, basically.
Yes, this is probably the most tricky part of this workflow. Most of all because I use KNIME, the data analytic platform, for its visual programming approach. I have, as you have shown in the first or the second slide today, I have a strong engineering and project management background. And then I decided to shift gradually to a computer science. So it wasn't simple for me to gain quickly an effective knowledge of programming languages. I want to be honest.
Sure.
So I decided to apply an engineering approach and asked myself, but do I really need to know some programming language? And which programming language? There are so many programming language are Python, Ruby, Java,
Yep.
anyone. Or I have to focus myself on data science. And how is possible? So after the deployment, the first attempt of deployment of a digital twin, I think that data science goes beyond programming skills. It's about logic and methodology. A data scientist's key task is to create a structured workflow from data collection to insight extraction. So visual programming simplifies the initial step, like for me, enabling direct interaction with data and allowing a data scientist to focus only to the algorithm, to analysis rather than technical programming, and improve it, so decision making and accessibility. Anyway, I want to be honest, some months ago, I couldn't resist to the temptation to dabble in SQL and Python language. So after all, I want to truly master digital twins, and I decided to embrace my inner nerd inside myself. So this is probably the most funny part of this situation.
Sure. I definitely understand that impulse. I myself have a background in coding, so I can definitely see the attractiveness of learning a new language. But I have to say this approach of trying to go with a low code to no code solution is actually very in line with what we usually do with Vcad. One of the reasons we decided to go with Power BI is exactly this. It allows you to do some truly complex things without needing to know how to write code. And so you don't have that initial obstacle. You can then go into all the technicalities if you want, but you can start with something simple that gets the job done and actually gets the information across.
Of course.
Yeah, and so actually, if going back to our steps, so the last one would be actually, I really like before you use the word narrative. I think that's a very good description of what we can do in Power BI. So you basically started using Power BI to then communicate this complex data because, well, data is cool, but it's not very useful if it's just cool. We need to be able to get it across and communicate it to others.
Of course, like probably any one of me and you, and probably some of our audience, it's impossible to present data to our manager because our manager has no time to read data. So we have to make we have to create a storytelling of data. So we have to use chart, colors, any kind of this possibilities for us. Yes. So we will be able to correctly communicate the information, not the data, but the information.
Yes, definitely.
With the information, we will be able to take the right decision.
Yep. Okay, that makes perfect sense to me. Okay. Well, let's dive in a little more into this last aspect. So the communication, and in particular the report you built. So we have today sort of the output of this project you followed in the form of a Power BI report that you created. So let's jump into the actual report. And while I load that up, would you mind telling us a little about the sample data? So we're looking at some historical data, correct? For what time period in particular?
Yeah, we had about 2 years of data, about 20,000 of data entry. with some situation of missing values, some outliers, and so it was important to correctly manage all of this in the most correct way.
Okay.
As it is the entry page. After the introduction, this is the first page. In the first page, you can see this is divided mainly in two parts. The first part is start and end date for data visualization. You can digit the date inside the two boxes, or with the slider you can stretch as you want. Okay. You have also on the right the total energy consumption for all the IoT sensor in kilowatt per hour. Okay. After that, in the below part, you have all the a data table with all the IoT sensor. These are filtered by group with sensor type that you can filter by color, by name, by.
So these are the actual instances of.
You can identify immediately by group by groups, and then after that you can see in the below part there is also a chart, a line chart with all the IoT sensor. The most tricky part is when you scroll with your mouse over one of the icon of the in the Vcad component, you can see immediately appear tooltip window where you can see the name of the IoT sensor, the total energy of that particular IoT sensor, the minimum and the maximum energy consumption within the period selected in the previous part, and the dedicated line chart of that particular IoT sensor. Why is this important to have also this kind of representation? For example, if you select the electric cabinet icon,
yes,
one, it's interesting because you can see that there is a very particular line chart. It is a seasonality, is a daily seasonality, a weekly seasonality, probably because the slider of the windows is quite large, but if you take it a little bit smaller, perfect.
Ah, yes.
Fantastic.
I see it now.
Immediately, exactly. You can see immediately the how it's possible to read the data. There is a seasonality, and this is important in a time series data analytic phase because it could be suggest a key to predict possible future energy consumption of that particular component. It is also important to have a digital twin. I want to show you a very interesting part. If you take the slider in a wider part of the date, there is a very deselect the light and power, perfect, and select water pump.
Okay.
Perfect. Okay.
Oh.
You probably in the March and February 2021. Yes.
So here.
Is a sort of a strange situation from February.
Sorry, it went too forward.
From February.
There we go.
For about 20 days, about a month, some of the IoT sensor didn't work properly. And the building manager didn't have this dashboard. So it took about 1 month to fix the problem about the IoT sensor.
Okay, wow.
About 30 days. But if you take in this case a weather part of the slider,
Yes.
there is a peak about in July 22. Yes, that part.
Yes, right here.
Also, in this part of the year, there were some problem with some IoT sensor, but in this case, the building manager, I have given him this dashboard, and was able to fix the problem of the icon of the IoT sensor in 1 day. So
Okay.
this is an immediate, an immediate situation is how possible a digital twin help a building manager without need about 1 month to fix a problem, and now he need only 1 day.
Yes.
It's
Okay.
a immediate, immediate goal achieved.
Yes, this is amazing to me. The fact that we can clearly see through these data readings the difference in having a digital twin and not having a digital twin. Without it, you get kind of guessing, and eventually things gets fixed, but it can take a long time. When you have this sort of direct connection, and as you were saying before, this bidirectional workflow from the sensors to the data and vice versa, then the issue gets solved practically immediately. This is amazing. Another thing I like about this dashboard here is that it, which wasn't built by me. Gianpaolo did all the work. I'm just showing it, so I can say it's nice. The thing I like is that it gives us an easy way to see the energy trends over time and have a general idea of how everything worked together. But importantly, here it's very simple to focus in and drill down into a single device or sensor. And so when I have those issues, I can very simply identify where the issue is, and I can imagine I could connect this to my management workflow, and then send someone to work on the issue. And it's as simple as pointing to the model and saying, okay, this guy over here, this one's broken, go fix it.
Oh yes, obviously you can also immediately direct the action, probably also of a global server, in order to allow him to where he has to go. He has to go. In this case, he has to go to fix the problem for the IoT sensor. If I remember correctly, in the chilled water pumps, probably took
Okay.
yes, for the chilled water pump. So you can directly send a communication to the global server and allow him to operate immediately where he need to take action.
Sure. Yes. Okay. Okay, great. Let's move along. Let's have a look at the next page of the report, which is energy consumption dashboard. So what are we looking at here?
In this case, on the contrary from the previous one, we have the energy consumption of the whole building. We have the same slider for the date selection, so we can decide to make a wider one or a smaller one, if you want to focus to a particular period or to a longer one. But I decided also to give the information of the total energy consumption, and also divided by group of sensors, because it's important to understand the work of energy consumption, because a building manager needs to focus upon the problem of manage the energy consumption of his building, but also to understand if there are some components, group of components that are working properly, or are having some troubles, or are having abnormal energy consumptions. In this case, the building manager, we could be able to verify the energy consumption globally and verify if the building and the systems that provide energy to the building are overperforming or underperforming.
Okay, so we basically have uh, data analysis for every scenario. So we can have the very detailed review in the first page that we saw, and then a more overarching global approach over here. Okay, are there any particular scenarios in which one is better than the other?
Yes, there is also an important element that probably I forgot to tell you. With the energy consumption item by item, with more detailed energy consumption divided by sensor,
Yes.
it could be possible to create a sort of predictive model that could be able to detect anomalies. But in this case, probably it's quite hard to have only by energy consumption data. It could be needed also other kind of data, because with only energy consumption, probably it's not possible to realize a machine learning model that could detect anomalies and create what I like to call a predictive maintenance application. But with also other kind of data could be possible to predict the maintenance, the predictive maintenance, and also to obtain very interesting savings in the managing of a building, of a lot of building.
Sure. Okay. Yeah. Because of course this can then be scaled over time and over multiple projects. Okay. And help us out not only fix issues sooner, but actually take action before the issue even presents itself, which of course would be fantastic. Okay. Okay. Great. So let's move along to the last page in our report, which is the energy consumption trends. So
yeah,
walk us through what's happening here.
This is quite interesting for me, and I think that could be useful probably for any professional, because after the deployment of this particular element, it's important to create a sort of point zero to have the energy consumption for the first year. So to the second year, building manager could apply a monitoring alert if there are an excessive energy consumption in the current year, and verifying it compared to the previous years. In this case, for example, unfortunately, the current year I had to detach the digital twin from the real data, obviously, because I couldn't have the access to the data now that I have delivered this project. But after, in this page, for example, is quite interesting, because the year -3, you can see there is a very low energy consumption if you compare to the years -2.
Okay.
Because in the year -3, there was a renovation of some part of the building. So we don't have to stay alerted for this excessive energy consumption in this case.
Okay. So yeah, so here we're looking at two different years compared to one another, and rather than being worried about why there is such a high energy consumption in year 2, we should consider that instead it's year 3 that is a little skewed because there was maintenance going on, and so of course the consumption of energy was reduced.
But with this kind of this dashboard, building manager can have a sort of thermometer to improve their performances year by year.
Sure. And in this case, what we would do is use year 2 as our baseline, because that's an average year.
or to tell it this in other words, in this case, the building manager can justify himself to his boss.
Yes.
And say, don't worry, there was a renovation last year, so it's normal to have an increasing energy consumption this year.
Exactly. But it's important to have that data and to be able to then
probably
explain.
The most important.
Yes.
The most important.
Exactly. Okay. Great. So I think this kind of covers the report. So we saw how we can use a bunch of different data entry and varieties to create our dashboard, reviewing our digital twin. We have a little time for questions. So everyone who's following along in the webinar, you'll find the questions panel where you can go ahead and write your question. And we can take it from there. And we'll try to answer as many questions as possible with the time we have. So let me just pull that up. And in the meantime, Pierpaolo, again, I want to compliment you for this, for the result of this report, which I truly find amazing and really interesting, sort of the work you did here. Okay. So let's pull up the questions. Oh, and also, so as I said, we'll try to get to as many questions as possible. If we do not manage to answer all of them, you can find our contacts now on screen. So we're happy to answer any other questions you may have later, or we'll try to get to them. If we can't, we'll answer later in an email. Okay, so let's get started. So first question, can we consider this report the final ingredient to create a decision support system? And do you know of other software that could contribute to this end? Pierpaolo, I'll let you answer this question.
Well, yes, definitely. For the first question, I think that definitely we can say yes. If we remember, without this dashboard, the building manager wasn't able to recognize a problem to fix for some IoT sensor. After having the dashboard, the building manager was able to fix the problem in 1 day. So we have an immediate goal of 29 days of effectiveness of the building manager. So I think that is possible to explain in a very I'm quite sure that can be affirmative the answer to this first part of the question.
Okay.
For the second part, I think that like in every aspect of life, there is always a space for improvement.
Mm-hmm.
In this digital twin, we have a complete human-in-the-loop decision-making process. So the human in the loop have to take the decision almost for everything. But probably we could apply, for example, some business rules that are automatically sent to the global server. So the action of the human in the loop can be reduced only to the most important issues. Another interesting part could be, for example, the connection to a BMS directly in a bidirectional connection. So after the decision, the digital twin is able also to make the correct action directly to the BMS system. For example, setting the temperature of a floor or part of the floor, depending on the structure of the BMS. Another interesting part to be explored probably could be also augmented reality, mixed reality, but in this case, I think could be useful to have, for example, a connection with the Unreal Engine or Unity, for example, in order to create the scene where the digital twin
is represented.
Yes.
Cool. Okay, nice. Okay, next question. How did you place the icons in the right objects, and how is it possible to customize them? Okay, I think I can get this one. So the icon placement in the model is done through Vcad's icon rendering engine, basically, which allows us to display icons either based on an object location or a coordinate system. So in a best case scenario, you would connect the icons to an item and the placement is done automatically. And always using a data-driven approach, you can customize both the icon image and color. So in this report, we're doing both. So we have a specific icon for each sensor, and then we're using data to apply a theme and a color to them. Okay, so next question. Have you already applied machine learning algorithms to this data? And is it enough data to make predictions?
Okay, it's a very interesting question.
Yes.
And probably I suspect that some of our audience have already seen some article somewhere, probably on your blog, or probably also somewhere in other situation. Okay, I think that we can show the other one.
Yes, so okay, so this is a work in progress, but we do have something that we can show that sort of answers this question, at least partially.
Yes.
So just give me 1 second.
While uploading, I'll try in the meantime to explain a little. For this digital twin, I have also deployed a particular machine learning algorithm. It is a neural network called the long short-term memory neural network that is able to predict with a good accuracy of about 80%, yes, 87%, the energy consumption for the following period of about 1 month.
Okay.
Obviously related to the last data recorded, in this case, probably 2023. So it was in the past, but try to imagine this like in the following month.
Sure.
It is quite tricky. Probably it could deserve a separated discussion to explain how it's possible to deploy a long short-term memory, because it's a neural network, and all the algorithms like neural network need a lot of data. In this case, I had about 20,000 data entry, so it could be enough to deploy a quite effective algorithm.
Okay.
For less data, probably another algorithm could have better performances with less data, but for now.
Okay, so we're basically free to also choose the best algorithm based on the amount of data we have. Okay, yes. Cool. And so here in this example, what we're seeing is a first prediction. So basically a month based on all the data you have, which I think already is very impressive. So just being able to see 30 days in the future is pretty cool in my book. Okay. So let me see next question. So we have one question. How many sensors are you using? Do you attach to every single piece of equipment in every building's space/room?
Oh, okay. How many sensors are using? I don't remember exactly. Probably in the digital twin, I used about 12. See if I correctly remember, but we can count on the first dashboard.
Yes, that's right. We can just have a look here. So how many sensors do we have?
These are probably a little more. Could be probably.
So it's 4 plus 6 air cooling, so that's 10, and then 5 for the power usage.
So 15. In this case, yes, the sensor was 15.
Okay. Okay, and I think in this case, we don't have a relationship between the sensors and the rooms, but there's
No.
nothing actually preventing us from having that.
Not a problem. It's not a
So,
problem for this particular project because it's tailored on the need of the client. But
sure.
in other digital screen, for example, I needed for another problem for space management. For it was my first digital screen. It was the headquarters of my company. I needed to explore the space management of the building, so I related the data, but this case was a different kind of data
Sure.
taken from a desk booking application. I related the data directly in the single room.
Okay, so we can also imagine, like in a case of a multi-tenant building, we could want that connection between the sensors and the tenants, and that's absolutely something that that we can do. Okay, let me see. I think we're running out of time. Maybe one last thing. I've seen a couple questions that touch upon this concept, so I'll just give a broad response before we close. So the gist of the question is basically how do we manage how do we manage in this case data refreshes and loading, and especially once the report has been handed off. So for this, I would say we'd have different strategies that we can follow, but in general, I would go with Power BI's integrated tools. So the idea is you can, once you publish the report, you can then set up something like an automatic refresh of the data, which will go maybe every day and read the data and reprocess it. If instead you need a more specific and quick access to that information, it is also possible to create live streaming data sets within Power BI using Fabric's new infrastructure. That is also a possibility. It really depends on the latency that you need. In this case, probably, I imagine, Pierpaolo, tell me if I'm wrong, but I imagine doing a refresh every day is probably sufficient.
It's quite sufficient to have a refreshing rate of about 1 day, or maybe also every 12 hours could be enough.
Sure.
Project, but the possibility of refreshing also from Power BI for NIME could be almost streaming data, or almost real time. You can have a refreshing rate of data wrangling, process data cleaning, and uploading to the to Power BI almost every minute. So yes. You can shift depending on your need.
Of course, yeah. So again, a key thing here is flexibility. So this is an example of a scenario and a project, but then this can be tweaked to better serve the specific project. Okay. So with this, I'm afraid we're running a little late. So there are some other questions, but we can't get to them right now. We will, however, answer you through an email after the session. And again, if there are any other questions, you can see our contacts in the slides right now. Feel free to reach out to both me and Pierpaolo. With this, Pierpaolo, again, thank you very much for joining us and for walking us through the great job you did here.
Thank you so much for this opportunity. I was very honored to have received this invitation for today. Thank you to Bilogic and Vcad for this amazing component that could allow me to exploit almost any kind of idea that I could have during my job.
That's very good to hear. Great. All right. Well, then, goodbye, everyone. Thank you for stopping by, and we'll catch you next time. Goodbye.
See you.